Hi, welcome to another part of this Power BI course, data modeling. And in this episode, we're going to be looking at theory of data modeling. I believe this is one of the most important aspects of data visualization, data modeling. What are you going to learn? You're going to learn about data model and its purpose in data analytics. You're going to be able to differentiate between the two kinds of schemas. You're going to be able to create and manage relationship between tables in Power BI. You're also going to understand cardinality and cross-filtering in relationships. Also develop basic data dictionary for a data set, and then identify and describe facts and dimension tables and their rules as well. Well, let's dive into the lesson properly. What is data modeling? A data model is a structure that defines how data is connected, stored, and accessed in a system. As a matter of fact, in Power BI, it is the foundation that allows multiple data or multiple tables to be used together through relationships and enabling deep data analysis and visualization. With data model, you can connect multiple tables together and then you can be able to derive or do some deep analysis. Purpose of data modeling: organize data from different sources. As we know, usually data is not usually from one source, it's from multiple sources in the real life scenario. So I know when you are in an academy or maybe a tech school, you are always given a data set most of the time, except if you have data model to work with. But most of the time, you always have your data source in just one place, and maybe cargo. But in the real life scenario, you don't have to pull data from multiple sources, and this is where data modeling comes in to help you connect those multiple sources together, those data you have gotten from multiple sources. It supports meaningful calculations via DAX. We'll talk about DAX a subsequent episode. DAX means data analysis expression. It's just as formula is to Excel, DAX is to Power BI. Then you have the next purpose is to enhance report performance and usability. Yes, so that you can increase the performance of your presentation or your report, and it enables business insight. Of course, the richness of your data gives deep analysis. So if you're able to connect different tables together from different sources, it gives more insight into your analysis. Let's give a simple scenario. You have the sales data in one table, you have product information in another table, and then you have customer info in a third table. So you have like sales, product, and then you have customer at different tables. So how do you connect all this together? Remember, sales is related to product is related to customer is related to sales, but how do they relate together? That's where data model comes in. So data model will actually let you to connect them meaningfully for analysis. Now I want to talk about the two types of model schemas that we have basically. So there are two ways that we could design schemas. So we can, by their feature, we're going to look at it by their feature based on the two schema, star schema, and then Snowflake schema. So let's start with the structure. So first structure, the first structure is that it's central fact table with dimension. So what that means is that you have a central fact table, then the dimension tables is going to surround the fact table. While the dimension in this still holds for the Snowflake schema, but this dimensions table is now normalized into sub-dimension tables, sub-tables as well. We're going to look at all of that in a moment. Simplicity. Look at simplicity. Snowflake schema is simpler, and then it is easy to understand. Snowflake schemas can be a little complex with multiple joins. You have to join this, too many joins. So it makes it very sometimes complex. Based on performance, star schema they have faster performance, slightly slower performance due to the joints. So because of the joints, it has to look through from this table to this table, so it kind of slows the performance. Use case: when do you use a star schema? Most of the time a star schema is recommended in Power BI, while in traditional databases we use Snowflake schema. Now let you look at the star schema. Based on what I told you earlier, this is your fact table. This table here is your fact table. So you see fact, reseller sales, and then you have your dimension table: dim product, dim date, dim reseller, dim employees, dim sales territory. So as you can see, these are all what dimension tables. So this is one dimension table, this another dimension table, this another dimension table, this another dimension table, and this another dimension table. As you can see, the fact table is at the center while the other dimension table surrounds it. So how to disconnect to each other? So let's try to connect these to each other. Let me change the color of my pen. Let me change it to, let me see, blue. Okay, good. So now let's see where this connect. Now look at the dim product table and the reseller sales. You can see where do they connect. You can see a product key here, you can see product key here. So connect this to this based on the product key. So this and this will be connected to each other. Then date key, as you can see, date key, is there any date key here? I can see due date key. We'll check that later and see if there are any other keys. Now reseller keys, I can see reseller key here, so I'll connect this with this. So based on the columns that are similar to the two tables. And then the next, I see dim employees table. I can see employees key. Is there anything like employees key here? So look at employees key here. So I'll connect this with this. So that's where they are common. And then I can see sales territory key. So good, I see sales territory key. Yep. Okay, good. And then determine this table we have not connected. We can see date key. I think this is what we're going to use, the date key. So most of the time you might not have the same column name, but if the idea is actually the same, we can actually map it together to get this. So this is how this connects to each other. That's for the star schema. You have one fact table at the center, every other dimension table connects to the fact table. And then you have Snowflake schema. This looks a little bit complex. So you have here your fact table. You have here your fact table. And then you have your dimension table. These are your dimension tables. This, and these 4 dimension tables that surround this. So this is looking like a star schema, but then you now see other tables like sub tables of the dimension table, like this, like this, like this, and like this. This one even has 3 sub tables. Alright, let's see how we can map this out together. Let me change the color of this pen. Alright, let's start. So let's see how we connect it. So customer ID, good. Customer ID connects to customer ID here. Then we can see date ID here. So this is date ID, connects to date ID here. And then we can see store ID. This is store ID, connects to store ID here. And then you see product ID here. We can see product ID here, connected to each other. Good. So we've connected these 4 dimension tables. Now let's see how this connects together. State ID, state ID. Good. So this connects to each other. for the state ID, and then we can see brand ID. That's how they connect. And then we can see city ID. Good, that's where they connect. And then we can see week ID with week ID here. And then we can see quarter ID with quarter ID here. And then we can see month ID here. So this is exactly how this Snowflake schema looks like. Now let's talk about relationship and cardinality. So when you talk about the cardinality actually describes the type of relationship that exists between tables. So first we have one-to-many, which is very common. Let's say one product to many sales. So that means many people can buy one product basically, right? Good. So many people are buying one product. That's one product to many sales. So it can be connected to many sales. That's one to many. Then you have many to one, which is the reverse of the one to many. And then you have many to many, which is not too common, but it needs to be done with care. We rarely use many to many. Most of the times either many to one or one to many, depending on the position of the table that determines which one you use. Most of the time is one to many, many to one. We rarely use many to many because of its ambiguity. That's why. Then you talk about cross filtering. So cross filtering is when you filter. How do you want the filter to affect the tables? So single filter direction means that filter flows from dimension table to fact table. Now let's go back to here. Flows for dimension table to fact table. So if I filter based on city, right? So if I filter based on city from the store dimension table, what happens is that say if I filter to Lagos, so this is going to show the sales ID in Lagos, customer IDs that are in Lagos, product ID that are in Lagos, date ID that are in Lagos, and store ID that are in Lagos. So if I filter based on year, say 2021, I'm only going to see the sales ID in 2021, customer ID in 2021, product ID in 2021, date ID in 2021, store ID in 2021. So we can see that you'd filter based on the dimension, and that's one direction basically. So bi-direction, which is both direction filters, is when you filter in both directions. Now this can be very, very risky. It's at a risk of ambiguity. That means you don't even know, you're really confused where the filter is happening. Okay, so most of the time we always stick with the single filtering. Talking about data dictionary. Data dictionary is a document that describes each field or column in your data set. So what does this column means? Name, whose name, names of customer, what's the next column? Price of what? Price of product. So like it tells price. So it tells you what each column really means. Sometimes you can have data set that most of the column name are abbreviations. So that's where you go to the data dictionary to check what each column really means. Why is data dictionary very important? It promotes clarity and consistency. Very important. So once you know that, you are not just assuming that this is what this column should mean. You know from data dictionary that this is what this column means. And it also helps team members to understand the model. So you want to know what each column stands for, so that you can understand how you're going to map out your model to design and build your model basically. Because if you don't understand what each column means, you would not build a effective model. You build a deficient model basically. It also assists in documentation and troubleshooting. So if you are having issues, since you know what each column means, say you have built your model but you're still having issue, you can go back to look at the data dictionary to understand what is going on. Now this is how a data dictionary would look like. So you have column name. So each column name will be listed, followed by the description of what each column name means. Now look at this customer ID. What does customer stand for? It's a unique ID for customers. Sales amount, what does it stand for? It stands for this total sale value. Region name, what does it stand for? Customer region, that means where they live. And then your next column is the data type. That is text. Now total sales value is decimal. Customer region is text, which is of course acceptable, reasonable. Then the next is table. Which table does it fall? So customer ID falls in the customer table, sales amount falls in sales table, region name falls in regions table. So this is exactly what the data dictionary would look like. Now let's talk about the role of fact and dimension tables. What role does this two table play? I've actually talked about each of these, but now let's look at them separately. Looking at the fact table, it actually contains quantitative data, that means measurable values. Remember in this example where we talked about building the model, right? We saw that this one. We saw that if you look at the fact table, which is the sales table, this fact table, this particular one. So we saw that you have sales ID, customer ID, product ID, date ID, store ID, right? Basically, you would have other things like the price, right? You have other things like the quantity, that also because it's a sales table. You have other things like price, you have other things like quantity. So most of the time, it is numeric, like quantitative, measurable, while the dimension tables are categorical, that means qualitative. So one other thing about the fact table that it's often very large. It's very large because there's repetition and repetition and repetition. For examples would be the sales data, sales table, revenue table, orders table. Because as people are ordering, customer can order 5 times and the thing will appear 5 times on the orders table. While the dimension table contains descriptive data used to slice and filter fact table. So we use the dimension table to filter the fact table. So and it's usually a descriptive data. What do I mean by that? That could be something like customers. So customer A, customer B, customer C, or it can be something like product A, product B, product C. So you can actually use, if you want to see only product A, you want to see the sales for product A, so you have to filter by the product table, which is A, and then it's going to show you in the fact table that is quantitative, basically. Looking at the difference between the fact and dimension table, so let's talk about the feature. We're going to like 2 features, the data type and the volume. For fact table, the data type is always around the numeric, that it's numeric actually, while for dimension table it's categorical. Based on volume, fact table is usually larger, dimension tables are usually relatively smaller when compared with the fact table. Examples will be sales amount, units, those are fact table, while dimension table would look like product name, product customer name, regions, and all those kind of things. That's the dimension table. So what's next? Next is we're going to look at the star schema with Power BI, like going straight into Power BI to build a star schema model. And I'm sure you're excited to do this with me. See you in the next episode.